Today we will make the hopefully long-awaited music box. At least you guys have asked me about it. The process turned out to be quite complicated, but rather interesting. Welcome to the W&M channel. In one of the older videos, I was cutting a similar knife blade with a laser and had an idea to make a music box in the future, but as a general rule, things are easier said than done. That is why a W&M channel video takes a while to create. Nevertheless, today we will try something new and see if we succeed. My family and I permanently moved to another city, and the move itself took quite a lot of time and effort. There is a good reason why some people compared it to a house fire, and only now I am getting back into the grooves of a tight working schedule. The first thing I tried to make was the comb, the very thing that produces that unique sound of a music box. By the way, in the past, music boxes used to be made by watchmakers, and sometimes it took them over 6 months. I hope our process will go faster than that. The knife is made of hardened steel, so we use a laser to cut it, just like last time, but this time we had to do a lot of trial and error. For example, here the metal simply overheated and naturally nothing good came from that. It seems that tempering has occurred and there are obvious deformations from overheating. This will definitely not make any music. So I tried the old option with the direct burn through and cooling it with a jet of air, but the teeth are very thin and they overheating again. So this option didn't work out either. In the end, I went back to the micro metal removal, layer by layer. On the first pass, a thin layer of metal is burnt, and on the second pass, the laser cleans it off. And just like that many times. To cut one comb, you need about 4 hours. The experiment took me a little over a week. Of course, this is not ideal, but it is something I can work with. First, we need to polish the visible part. On the reverse side, there is still some metal that needs to be removed, so that the slots are visible. Let's do it with a solid ray in a few passages. After that, we grind the space between the teeth by hand. Finally, you can get the first sounds. They are certainly far from perfect, because I made them, as they say, by eye, but at least that's something to work with. Align the front sides, and now you need to drill the holes. After the laser, they turned out slightly oval, and so we drilled them out with a carbide mill. I drilled so many holes for a reason. It's just that fixing this plate and getting the sound you want is fundamentally important. Lubricate the teeth well towards the end with active flux, which contains orthophosphoric acid. This will help make the soldering reliable, and why we need the soldering, I'll show you a little later. We do not go stingy with the solder because later in the process we will modify it all anyway, since it's only the first try. It came out as this sandwich and now we need to separate the teeth from each other. I quickly made this thin milling cutter and now we will cut the grooves between the teeth. Solder metal is very soft. When milling it, you need lower revolutions and preferably some coolant, but we'll just clean off the adhering solder with a toothpick. Cheap and easy, as they say. After a little polishing, we now have these weighted teeth. The sound is completely different. Rather, thanks to the soldering, the frequency of each tooth has decreased. Now we can tune them to the desired notes. We mill it a little and the frequency increases. If we messed it up, we put the solder back on and try again. Turns out that it is impossible to tune them at the stand. We will have to make a frame. You've probably seen this in regular pianos. There is this kind of metal base in which the strings are stretched. We will make something similar, but instead of cast iron, we will use aluminum. The frame itself will be attached at the wood resonator. It's like a guitar body. Later, we will attach the drum with a hand crank mechanism to it. It is going to be this kind of musical sandwich. But will it make sound? Let's take a look. To attach to the resonator, drill 4 holes. This is the first time I make this kind of contraption, so for sure it will have to be adjusted later. We drill the holes for attaching the comb and we cut a thread in them. The thread could be cut by hand. but I really don't want this design to have even the slightest deviations from the vertical axis. We cut off the workpiece and now we need to give it the proper look. Final polishing will be done after assembling the whole structure, but at least there shouldn't be any burrs at this point. This is the first time I try turning the reserve head. Turn it 90 degrees for internal surfaces processing. At the bottom of the vertical column, there is a limit. So let's raise the workpiece a little, fixing one vise into another vise. If you remove the retainer, you can position the head at any angle. I think that will come in handy in future projects. We will make the pressure plate from brass, and it will not have direct contact with the aluminum. I think with the small size it will be easier for it to keep the shape. Thickness margin of 2 mm. I think it will be enough to flush the screw heads. On the reverse sides, I remove the chamfer so that the main clamping force goes along the edge and not along the body of the screw. For now, we will also polish it, but I think in the future we will seal it. Well, it's finally time to attach the comb in its place. The M1.4 screws provide little force, but given their number, I think this will be enough. The most important thing is that between the comb and the bed there should not be even a micron gap, otherwise there will be a very unpleasant rattling sound. After being completely sure that we will definitely not disassemble it anymore, we can start with the fine-tuning. I had to solder some spots and cut a little here and there. Overall, I spent almost an entire day of work tuning it. Next, we will make the resonator. It will also be the basis. Fir would probably be more suitable for this, but we will make it from a more valuable kind of wood – beech. And beauty is certainly not the issue here, it's just that beech absolutely does not cheap when it comes to fine details, but fir might. We cut off the lower part and the thickness at the bottom comes out as only 1.5 mm. Now we will make a cover. It will also be a pretty thin, about 1.5 or 2 mm. Yes, it won't be a classic version of the music box, because essentially the box itself is not here, but the way they produce the sound is the same. Here we make 4 holes for attaching the frame with the mechanism, a hole for the part of the cylinder that sticks out, and the resonator holes. We trend both pads and everything is fine. Now we can cut. We cut off all unnecessary things so that the workpiece fits in terms of height and cut it leaving a bit of a margin. And now we fix it on the previously prepared table and remove excess material. Small stripes remain after the cutter. We grind them out as well. On the underside of the top cover, we will glue the corresponding frame. Let's make it out of thinner sheet aluminum. It is necessary to press the frame well against the resonator, so that there are no random parasitic vibrations. Cut the thread into the 4 holes in it. There will be no inside access after gluing the resonator, so we also glue the frame itself using the 2-component adhesive. Everything seems to work out well, and we can glue the cover in place. When the frame was just on the table, the sound had one kind of ring to it. With a Resonator it is completely different, also without it was very quiet. I've also decided to experiment a little and connect the top and the bottom covers with two dowels. First, the design will be sturdier this way. We have a crank mechanism, so this is important. Second, the vibration from the frame will be transmitted directly to the upper and bottom covers. Is it good or bad? Let's see. Unlike when gluing the frames, we do not use the two-component glue here. This time it's the real carpentry glue. After all the manipulations, the top of the cover must be pressed firmly. Well, after the glue dries, we proceed to the finishing touches. This grinder is designed for metal processing. It has a very high speed, so the wood needs to be sanded very carefully. As they say, if you really want something, you can do it. Naturally, the final processing is manual. This is the only way to achieve the result we want. The dowel seems to be glued well, so they can be coated with oil now. If you remember from past videos, it is not just oil, but oil mixed with varnish. I think when the box is completely ready, we will give it another coat of varnish. We give it a little time to soak in, dry, and return the frame to its place. The process turned out to be quite complicated, requiring a lot of time and skills. Therefore, the video will have to be split in two parts. In the next part, we will make the drum with the melody, and the mechanism then rotates it. In the meantime, let it just be a micro-musical instrument. If you press the resonator against the table, you get more of a hollow sound. I think we will also make it some legs. I hope you are also curious about how it all worked out in the end. Until then, bye-bye.